Multiplying special cases. What makes you so special? What makes you so special? A lot. It's very easy to do these problems. That's what makes them special for me. When I see that, I'm sitting at my desk and I'm like, yes, this one's a piece of cake. I can do it real quick. Okay. These are special cases because there's a special rule, something that you can do to solve a problem like this and like this very, very quickly. Okay. Now, could you go about this using the FOIL method? First, outside, inside, last. Could you also use the distributive property, the table method, which I showed on previous videos? Absolutely. That's a long, drawn-out way of doing this when really all you have to do is know the rule. What makes something like that so special is the fact that they're the exact same binomial, x plus 9 and x minus 9. The only difference with them is one we're adding and one we're subtracting. Same over here, 3c minus 4, 3c plus 4. One we're subtracting and one we're adding, but it's the exact same values being multiplied by each other. This makes them special, and it makes it that there's this rule that we can follow. A plus B times A minus B. What this is saying is if I have the same two starting values, and then I'm adding on the first one and subtracting on the second one, and the same second values, okay, then I can do this. I don't need to do the FOIL method, multiply everything together. I just know automatically that my first value, my first term, is going to end up being a squared. And then I'm going to take this value right here, and I'm going to say minus b squared. And I am done. Okay, it is as quick as that. So my first term here is an x, so it gets squared at the start. My second term is a 9 minus whatever 9 squared is. 9 times 9 is 81. I'm done. Instead of me multiplying a bunch of things together, I can just go right there to that, and most of you should be able to do it mentally. All right? That's all this rule is. It's just a route, a quicker way, a shortcut to get to a result when you have something very specific, a special case coming up. 3c minus 4, 3c plus 4. All right, well, 3c squared minus the 4's squared. That's all that's saying. Big thing here is you got to have the parentheses around the 3c because that exponent of 2 needs to go to the c and to the 3. This is going to give me 9c squared minus, that would be a 16. And I am done with this one. Now let me prove to you that this works and why it works every single time. This is not a sometimes rule. This is an every time this pops up, you will get that as a result. Why does it work? Let me do this problem over here for you the long way, and I'll show you it's the exact same result as this. So if I were to go about this problem using the FOIL method, I would do my first terms, and I would get x squared. Then I would do my outside terms, 9 times negative, x times negative 9, which would give me negative 9x. Then I would do my inside terms, which would give me a positive 9x. And then I would do my last terms, positive 9 and negative 9, which would give me a negative 81. Every time this happens, every time you see that type of a scenario, your like terms in the center are going to cancel each other out. Negative 9 plus 9 makes a 0. So really all you're left with is these two amounts, x squared and negative. It will always be a negative because one of them is a negative, one of them is a positive. You get a negative result right there. Okay, hopefully this shows you why this rule works. And you might be like, oh, another thing to remember or another rule to learn. I'm telling you right now, if you see this and you know that that's the law or the rule to it, you can go through these problems much quicker than a student that wouldn't know this stuff. So it is worth the time to learn. It is worth the time to study and practice because once you've done enough of them, it will become muscle memory. You'll notice them right away, and you'll be like, oh, I can do that right there whenever they pop up. Good luck on your upcoming test. Study hard.